In this video we'll be going through the anatomy of a parabola, so we need to understand all of this vocabulary in the very beginning when we start looking at quadratics. And just so you understand, quadratic functions produce parabolas as their graphs. Like linear functions produce lines, quadratic functions produce parabolas, so they're these U-shaped graphs, and we'll see that they can open up like this one or open down like this. So, major vocabulary is right here. Axis of symmetry, very important. The axis of symmetry is the imaginary line right down the center. So I'm using orange here for that. It's an imaginary line right down the center of the parabola. It's called the axis of symmetry because it's the axis where the parabola is symmetrical about. So if we were to fold this side, so everything to the right of the axis of symmetry over, it would lay directly on top of this side, and vice versa. The axis of symmetry is always denoted as a vertical line, and when we talked about lines, you know that vertical lines are described as x equals a number. So in this case, that x equals 0. So x equals 0 is the equation for the axis of symmetry. So I'm going to write, we usually abbreviate that AOS. Okay, the axis of symmetry is very important that you understand the concept here. So for example, if I find a perfect point right here of 3, 5, we also see that this parabola has the point -3, 5 as well. So you notice that the y values repeat. Now what's important about the axis of symmetry is that when your y coordinates repeat, so we have a y value of 5, a y value of 5, those values horizontally, so left and right, will be equidistant, meaning the same distance from the axis of symmetry. So it's 1, 2, 3 away on this side, and 1, 2, 3 away on this side. That will always be true. The matching point, so the y value that is shared, will be equidistant left and right from the axis of symmetry. So that's important to understand about the graph of a parabola. All right, vertex. Vertex in this case is going to be a minimum. So the vertex is a minimum. The vertex is this very bottom point. It's the lowest point, the minimum point. I'm going to use another color here. We'll use green. That point right there. So the vertex for this one is 0, -4. 0, -4 is the vertex, and we want to label it with words here. Vertex, and it is a minimum. We'll abbreviate min. So notice that's the lowest point. That's the lowest y value that this parabola will ever have. We should draw arrowheads on the end of this because this goes on forever. This side drifts left and up. This side drifts right and up infinitely. Okay, next part, roots, zeros, x-intercepts. They're listed together because they mean the same thing. The easiest word to understand is the x-intercept. They all mean the same thing in this case, but x-intercept makes the most sense because it's where it intercepts the x-axis. It's where it crosses or touches the x-axis. So that would have roots, x-intercepts, and zeros of 2, 0 and -2, 0. Alright, so we'll label, I'll just label once. I would like you to label them as all three because I want you to get used to understanding. And most problem situations, they will either discuss x-intercepts or zeros or roots. So you need to know they all mean the same thing. You'll also note that when you have roots like this, in this case, they're equidistant from the axis of symmetry as well. So the second example here, we'll start with the axis of symmetry. So the axis of symmetry is the imaginary vertical line. We usually put a dashed line to sketch it in there. And it's always denoted as x equals the x value, so x equals 2 is the axis of symmetry. It's always specified as a vertical line. X equals a number. The vertex in this case is right up here. We always list that as an ordered pair, so the vertex of this graph is 2, 4, and in this case it would be a maximum. We'll abbreviate max like that. So the vertex ordered pair is 2, 4, and it in this case is a maximum. So the parabola is going up, hits its maximum, turns back down. So x is increasing, y is increasing, both increasing here. You get to this inflection point, this turning point, x continues to increase here, but y is now decreasing. Important to understand, that's the turning point, the vertex. And we said it's a maximum, so I'll circle that. And roots 0 is x-intercept. So that means where does it cross the x-axis? So right here and right here. So that would be at the origin, 0, 0, and 4, 0. And if you notice here, these roots are equidistant from the axis of symmetry. They're both, in this case, 2 away. And that will be the case when you have a parabola that crosses twice, like this one does. Let's label all 3 words, roots, zeros, and x-intercepts. I'll abbreviate x-intercept. So they all mean the same thing. In a problem, if they tell you have roots of 4, 0, and 0, 0, it means where it crosses the x-axis in this case. They may use x-intercept, they may use 0, they may use roots, but in this context, they all mean the same thing.